comprehensive automated system for measuring the fissile content of 3013 containers has been designed, built, and tested by ANTECH for deployment at the mixed oxide fuel fabrication plant being constructed by Shaw Arriva Mock Services at the Savannah River site in the United States. Fissile material, plutonium, in 3013 containers is handled by a 3-axis gantry robot and measured in sequence by a weigh station, a calorimeter, and a gamma-ray spectrometer, and then placed in temporary storage. The Automated Fissile Material Measurement System, or AFMS, employs 3 calorimeters to determine sample thermal power and 2 gamma-ray spectrometers to determine the plutonium isotopic ratio data. As many of the 3013 containers will enter the system at elevated temperatures, 3 preconditioning units have been included and associated with the 3 calorimeters. The role of each preconditioning unit is to bring the 3013 sample container to the calorimeter operating temperature, which is typically 25 to 30 degrees centigrade. In the test facility, once a 3013 container is received, it is transferred to the weigh station by the gantry robot. Each container may weigh up to 12 kilograms and typically may contain approximately 4.5 kilograms of plutonium. After the weight has been determined, the container may be transferred to the lag storage, where up to 28 containers are temporarily stored while waiting for measurement. Alternatively, if a calorimeter preconditioner is available, the 3013 container will be transferred directly to an available preconditioner. As with the transfer of containers to all of the measurement stations, the gantry robot must first remove the plug unit and place it into a parked position. The sample is then inserted into the preconditioner. Once a plutonium sample in a 3013 container has reached the calorimeter operating temperature, it can be transferred to a calorimeter if one is available. Again, the calorimeter plug unit is first removed by the gantry robot and placed in a parked position. Once the sample is inserted into the calorimeter, the gantry robot repositions the plug unit. The calorimeters, which are of a novel design, can be operated in either isothermal or heat flow mode. Because of the requirement to dissipate up to 15 watts of thermal power or heat from each 3013 container, the isothermal or power replacement mode of operation has been selected. The thermal element of each calorimeter consists of 3 concentric thermally conducting cylinders separated by a thermal semiconductor. A 3013 container is placed in the inner cylinder, which serves as the measurement chamber or measurement well. Sensitive thermopiles are employed to measure the heat flow between the inner and middle cylinders. The calorimeters achieve excellent measurement precision and accuracy of better than 0.2% above 0.6 watts and a sensitivity of 341 microvolts per milliwatt in heat flow mode. At the conclusion of the calorimetry measurement, the sample is transferred to one of the 2 gamma-ray spectrometers. Again, the transfer process involves removing first the gamma-ray spectrometer plug unit and then removing the calorimeter plug unit prior to transferring the 3013 container. After the container has been transferred, the plug units or lids are replaced in sequence. The gamma-ray spectroscopy isotopic ratio measurement system uses a shielded high-purity germanium detector of high resolution. The system employs a container rotation mechanism and an automated aperture shutter to optimize the detector dead time. The plutonium isotopic ratio data is calculated from the measured gamma-ray spectrum obtained for each sample. The 3-axis gantry robot has longitudinal x-axis movement of 7.2 meters, y-axis lateral movement of 2.3 meters, and a vertical ram providing 1.8 meters of movement in the Z or vertical axis of travel. The vertical axis incorporates a compensating end effector to overcome the problem of misaligned 3013 containers. A pneumatically operated compensator provides limited X and Y plane adjustment, and the 3-jaw pneumatic gripper with a gimbal provides 2 further degrees of freedom in both pitch and yaw. Following the gamma ray measurement, the 3013 container is ready to enter temporary storage. The sample transfer is accomplished in a manner similar to the earlier sample transfers involving the Gantry robot removing the plug unit and placing it in a park position. The Gantry robot transfers the 3013 container to an output conveyor, which is simulated in the test facility by an elevated stand. From this position, the container is transferred to temporary storage by the conveyor, which is supplied by others.